Seeking English, S.A.T. Workbook, page 469, problem 2, no calculator, and I cannot think of a way to use a calculator on this problem. The book offers some explanation of how to approach a problem that looks like this graphically, but I need to give you a little more value than that, because even seeing this specific problem the first time, various things popped out at me. Okay, and it's not because I have some supernatural ability to have things pop out. Okay, it's not that. The key to being able to spot hints or clues in a problem is not, there's no magic pill. You have to just look at enough problems enough times and to take them apart analytically, as if you want to solve not only that problem but to solve related problems. So hopefully by the time you take the test, what I've told you here will be in some way useful to you. The answers are what you are going to use to decide which is the correct answer or the wrong answer a lot of the time. It says 4x minus 3 over x plus 2 is equivalent to which of the following? A hint that something is the correct or incorrect answer here is that, first hint, I can't see an immediate way to completely eliminate both of those x's. Okay, my intuition about fractions says I'm probably going to be stuck with at least one of those x's at the end of the process. So A and B are probably not very good answers. C and D probably are good answers. Now I'm always saying go after the simpler answers first. Okay, but what's graphically simpler is not always really simpler. The simpler answers are the ones that are going to require the least activity to get you from where you start to the answer. So if you start with those two x's and then you end with two answers that have x's in them, those are actually probably the simpler answers in this case, because getting rid of two x's could be a lot more complicated than getting rid of one x, especially if it's impossible. That's pretty complicated. Okay, enough about that. Answers A and B are each reducible to a simpler expression, and that's never a good sign. That's never a good sign. But the thing that hopefully would pop out for you on the test in a problem of similar design would be that 3 of these answers have a 4 in them on the left, and the top one does not. So that's a hint that if you pull 4 off of the fraction, it's either going to produce B, C, or D in the process, or it's not. Okay. If it doesn't, then A is probably your answer. You don't have to think about it anymore. And don't go any further. Okay? So what I'm going to do is I'm going to pull 4 off of the fraction and see what precipitates from that. Okay? It almost has to be B, C, or D. There's almost nothing else that can happen. Some fifth possibility is not allowed to you. So just let's try it, see what happens. Okay? Where am I going to get that 4? Well, it is a property of all fractions that whatever is in the denominator is included both positively and negatively an infinite number of times in the numerator. That sounds crazy, doesn't it? It does, but it is nonetheless true. This x plus 2 is present both positively and negatively an infinite number of times in the numerator. You just don't see them because they cancel each other down to 0. So if you imagine a 0 here, okay, say I'll call it plus or minus 0 just to be really confusing. That plus or minus 0 consists of an infinite number of x plus 2's and negative x plus 2's, which are added together. So if I wanted to pull a 1 out of the fraction, and I hope I'm not skipping a step here, if I want to pull a 1 out of the fraction and put it over here, all I have to do is take something off of the numerator, which would be equivalent to 1 as in terms of the way it relates to the denominator. So I'm gonna put this minus x plus 2. Okay, so this minus x plus 2, this minus x plus 2 over x plus 2 is a minus 1. It is equivalent to this one which I added over here. So I now have an expression with a 1 pulled off of the fraction. That is, I think of it as being pulled off the numerator, but the idea is you pulled 1 out of the fraction and you put a negative 1 into the fraction this way. So if we wanted a 4 here instead, what we'd want to do is just do this 4 times. I'm not going to do that graphically because there isn't space. What I'm going to do instead is I'm going to put this minus 4 times x plus 2. Okay? To get rid of the brackets, which is an obvious step that I probably want to do next, is this minus 4 and this 2 produce a minus 8. Okay. And that produces, that's minus 4x and minus 8. This plus 4x and minus 4x cancel each other, 0, okay? And this minus 3 and this minus 8 produce an 11. And that's probably up in the, yeah, it's a little bit up in the glare. But that's a minus 11. So that becomes 4 plus minus 11 over x plus 2. Okay? And if you see that's a minus, you can move the minus out there. Okay? So that's, for me, that's the process. And your algebra teacher probably has something different. And it may even be faster. The reason I want you to see this process is that it is very applicable to a very large number of problems which are not necessarily related in a very direct way. Okay? If you only remember one thing from this lesson, please remember what the crazy thing that I've told you about numerators and denominators. No matter what the denominator is, it is included positively and negatively an infinite number of times in the numerator. You just don't see it because they cancel each other out. So you can pull any integer out of the fraction by accommodating accommodating that graphic necessity to show that you've made that adjustment in the numerator as compared to the denominator. If this is still confusing to you, good. Okay, it is conceptually bizarre to a substantial number of students. So go ahead and watch the video again. And as always, if it was obvious to you, great. It is not obvious to everyone. Thanks.